The Internet of Things is quickly changing our lives as smart products proliferate across almost every industry, in every facet of our lives, making simulations like the one you're about to see a valuable tool in the product development process. Because smartwatches are becoming increasingly popular, the ability to design and optimize them using Ansys solutions is critical. These bands track exercise performance by monitoring the user's blood pressure, pulse rate, distances, times, and more. They also act as a media player to display messages on an LCD screen and stream music from a small storage device built inside. During the design process, it is critical these systems are perfectly integrated to guarantee reliable performance. Let's start with the electronics. We want to first design an omnidirectional antenna that can meet electrical and marketing specifications. We also need to design a 3-layer circuit board within a 4x4 centimeter square area. To design the wristband layout, we use Ansys SpaceClaim to draw the geometry. SpaceClaim offers several advanced drawing capabilities, allowing users to easily create a sketch. You can then extrude faces, edges, or points from any sketch. You can also use the wrap feature, which is extremely helpful in the antenna design here. As you can see, with one bottom plate, you can grab the 2 antennas on the mechanical part. Ansys HFSS simulates the antenna and the other critical components. HFSS gives the user an interactive 3D desktop where he can draw, view, or rotate 3D structures with ease. With a quick electromagnetic analysis, as you can see here, you can analyze many things. For instance, the surface continuity on your PCB. You can also view the S parameters, which show you how well the antenna is going to be matched. Finally, you can look at the radiation properties in the near field or the far field regions. This way, you can predict the antenna performance before fabricating the design. We can also make sure that critical interconnects were designed correctly and can handle high-speed signals once placed on the PCB. This can be done by simply using linear circuit analysis within the electronics desktop. You can start by adding an input signal and measuring the receipt signal on the other side of the interconnect. We can increase the speed of this signal and see at what point it starts to fail. For the memory cards, the specs tell us we need to have a line that supports up to 450 megabytes per second. We can see that the received signal is recognized easily up to 1 gigabyte per second of these nets. This tells us that we have good design for these interconnects. On the other hand, if we look at the USB interconnect, we see that it fails at 2 gigabytes per second. The target design here was 5 gigabytes per second. So we know ahead of time that this interconnect will not receive the signal at high speeds. We now can revise the design of the specific nets and optimize the problem until we meet the target specs. This shows you how critical it is to run simulation before manufacturing. Knowing this early in the design process saves valuable time and costs. Now let's move to the mechanical side. Here we will be concerned with 3 main areas: reliability, manufacturing, and user experience. The number 1 failure of wearable products is due to impact or drop devices. Simulation can determine the effect of an impact on a device before prototyping, enabling designers to improve the device's durability and reliability. In this animation, we can see the formation before impact, and we can also see the damage to LCD screens and prevent this with design modification. Wrapping the antenna can introduce stress and can cause failure during manufacturing. Ansys Mechanical simulates the stress during the forming of the antenna. In the initial design, the stress around the band was too high. This was adjusted to improve reliability. Additionally, the wristband needs to stay cool during usage, as excessive heat can lead to perceived problems and user discomfort. Here, we can perform a multi-physics simulation using the power generated within the PCB already computed with Ansys HFSS as a source for the thermal problem. Ansys Workbench can maintain a bidirectional link between electronics and mechanical tools. Finally, What will happen when the device is used in real-life scenarios? Can this be simulated before testing? The answer is yes. In this example, we added a wristband on a human body model. We also added a Bluetooth speaker to act as a receiver. There are two known electromagnetic sources placed close to the wristband. The simulation involves the entire room, with the main goal of testing the performance of the wristband under high noise levels. We can see here the wristband was able to handle noise up to -10 dB. If we use off-the-shelf components for the antenna in this design, the wristband fails at -26 dB level of noise. This tells us that the antenna design in HFSS can handle 16 dB of noise once placed in a realistic environment. The Internet of Things is exploding. So is simulation as the engineering tool to make it all happen.